You just watched a video that introduced some basics of circles, some basic circle vocabulary and some basic circle relationships. You also got to find out how you did with your lab activity yesterday. So if you didn't make the connection from the video, each of your answers, if you had measured perfectly when you did your dividing, so circumference divided by diameter should have given you a little more than 3. Or if you had measured perfectly, 3.14 pi. Some of you are quite close to that. Some of you guys were in the right neighborhood. What we're going to do now is we're going to take a few minutes together and summarize some ideas from the video that you watched into some notes that you can put into your table of contents in case you need to look back at them later. And we're also going to talk a little bit about using some of the ideas that were introduced in the video. So we are going to do our notes together. So as we fill them in, you're going to follow along and you're going to fill in your notes. So the very first thing from the video was some circle vocabulary that we should probably write in our notes. So you got introduced to the idea of the center of a circle, the radius of a circle, the diameter of a circle, and the circumference of a circle. So right at the top of your notes, we have a place to record some information about that. So we're going to mark each of those things on the circle, and right below it, we're going to fill in a quick definition based off of what was introduced to you in the video. So the center of the circle, we learned, is right in the middle of the circle. And the thing that's special about the center of the circle is that all of the edges of the circle are the same distance away from the center of the circle. So we can make a note about that on the bottom. That's how we know where the center is. So all points on the circle are the same distance from the center. So that's the center of the circle. You also learned about the radius of the circle, and the radius is that distance. So that distance from the center to any edge of the circle, and it's the same all the way around the circle, but that distance, because it is what's making up the circle, it gets its own special name, so we call that the radius. So it's the distance from the center to the edge of the circle. If we go all the way across the circle, so from one edge passing through the center to the opposite edge, that is the diameter. So distance across circle through center. And the last part is the circumference. So the best way to draw the circumference would be to kind of show a little wrap around there. So the circumference is, it's like the diameter but for a circle. So it's the distance around, the distance or the diameter, or sorry, perimeter. The distance or the perimeter around the circle. So circumference is another word for perimeter, but it gets its own special name when we're talking about circles. So it is the perimeter or the distance around the circle. The other thing that was mentioned in the intro video that you watched was some connections between these different things. So the video talked a little bit about the connection between the radius and diameter, and also a little bit about how to calculate the circumference, which is the idea that you were exploring in your lab activity yesterday. So we should probably get some things into our notes about that, and we're also going to add in some examples of actually calculating with those things. So one thing from the video that you got was the connection between the radius and the diameter. So if we have a circle, I'm going to draw one off to the side here. So that is the radius. And if we take the radius straight across the other side, that's the diameter. So the diameter of the circle is always twice the length of the radius because it takes 2 of the radius to make the diameter. The diameter of the circle is twice the length of the radius. If you wanted to put that into an equation, which you'll see out there, it would look like this. Diameter equals 2r, or 2 times r. We're working with variables, and we have a number and a variable right next to each other like that. It means to multiply. So you'll see that equation floating around, and that's just the equation that says it takes 2 of the radius to make the diameter. So we can use that to do some basic calculations. So a couple of quick examples of using that. Let's find the radius of a circle with a diameter of 48 centimeters. So the diameter is all the way across the circle. It takes 2 of the radius to fit in that, so that means the radius is going to be half of whatever that distance is. So if I have the diameter and I want the radius, I can just take the distance all the way across and divide it by 2. So that means my radius has to be 24 centimeters. You can also do that the other way around. If I'm starting with the radius and I want the diameter, again, it takes 2 of the radius to make the diameter. So if I'm starting with the radius, then I would need 2 of them to get all the way across the circle. So I can take that and multiply it by 2. So if the radius is 9, the diameter all the way across would be 18 inches. So you can do some simple back and forth calculations using that connection between radius and diameter. Now, the last connection, and this is the one that you were exploring in your math lab yesterday. So yesterday you had to take some different objects and you had to measure what we now know is called their circumference and their diameter, and then you did the circumference divided by the diameter. In other words, you made a ratio of circumference to diameter. In the video, you got shown using the computer to help a very accurate version of that, where you could see that it took a little more than 3 diameters to go all the way around the circle. So if you were measuring perfectly in your lab yesterday, when you did circumference divided by diameter, you should have been getting numbers that were around 3. And several of you did get numbers that were around 3. So we know the diameter of a circle fits around the circumference of a circle a little more than 3 times. Actually, from the video we learned it's 3.14, or pi times. So the way we can use that to actually figure out how long the circumference is, for those of you that are visual, that was a poorly drawn circle, but you will get the point. So it takes a little more than 3 diameters to go all the way around the circle. And then we've got a little bit of leftover right there. So however long that diameter is, we can multiply that by 3 plus a little bit of extra, and that'll give us the actual distance around the circle. So if each of these lengths was 2, then it would be 2, and another 2, and another 2, plus 14 hundredths of 2 to get all the way around. So rather than going 2 plus 2 plus 2 plus that extra little piece, the shortcut for that would be to just multiply. I need 3.14 groups of 2. So in other words, to get the circumference, I need 3.14 times however long the diameter is. Now there is an alternate version of this, and it has to do with the connection between the diameter and the radius. So we also know that we can make a diameter by doubling the radius. So I could also switch that out, and sometimes you'll see a version of the equation that looks like this: 3.14 times 2 times the radius, because 2 times the radius is also the diameter. So you can use that to do some basic calculations to find the circumference, or the distance around the circle. So there's a couple of quick examples. So circle has a diameter of 6 meters. So it takes 3.14 of those to get around the circle. So 3.14 times 6. And that works out to 18.84, and we're measuring in meters, so that means our answer is also in meters. When you're measuring lengths like this, you really should be labeling your units on your answer to keep track of what you're calculating. So that is something that I'll be looking for in your work, is whether or not you're labeling your units. So last one, find the circumference of a circle with a radius of 15 millimeters. Well, it's diameters that we're measuring around the circle, 3.14 diameters. So in order to get that, I'm going to have to double the radius and then multiply it by 3.14. So if I double the radius, I get 30. And then 3.14 times 30 gives me about 94.2, and we're measuring in millimeters. MM is the abbreviation for millimeters. So about 94.2 millimeters. And again, I'm saying about because when we use 3.14, that is not actually pi. As you saw in the video, it's a rounded version of pi, but it's what most people use when they're calculating with pi because it's accurate enough that it gives reasonable answers. So the actual circumference is not exactly 94.2. It's actually a little bit different than that, but that's pretty close to what it actually is. So there you go. We just summarized the circle intro that you watched. So now you have your notes outline complete that you are going to put in your table of contents as part of your work today so that you remember those things that you saw in the video. Once this is in your table of contents, you can go ahead and move on and work on the practice assignment for today.